morning, students. As already in fourth class, we have considered the order of reaction, molecularity of reaction, half-life period. Half-life period for zero order reaction, first order reaction. Today, in this fifth lecture, we are considering temperature coefficient of a reaction. As you know, the rate or velocity of a reaction is depends on temperature and catalyst. It affects rate of reaction. So today two factors we are going to consider: effect of temperature and effect of catalyst on rate of a reaction. There is one term, that is the temperature coefficient of a reaction. What it is found that as and how the temperature increases, rate of reaction also increases. And it is found that for every 10 degrees centigrade rise in temperature, the rate of reaction doubles or triples. And that factor is called temperature coefficient of the reaction. Let us consider mathematical and the words definition. The ratio of rate constant of the reaction at a particular temperature to the rate constant of a reaction at a temperature 10 degrees centigrade lower is called temperature coefficient of the reaction. Mathematically, we can write temperature coefficient of a reaction is equal to Kt plus 10 temperature. Kt, rate constant at 10 degrees centigrade low, is approximately 2 to 3. So it means that for every 10 degrees centigrade rise in temperature, the rate of reaction doubles or triples. Understand? So for 2 marks, that is what is temperature coefficient of the reaction. So either this or this we can give the definition. Next is energy of activation. E is energy, A is the activation energy. What is energy of activation? The minimum extra energy possessed by a reacting molecule to form the product upon collision is called activation energy, and it is represented by EA. Okay. So whenever the reactant is converted into product, the energy is possessed by the reactant in order to convert the product. That energy is called energy of activation. Understand? Now there are various forms of Arrhenius equation. First form and direct reactant third form, because this is important, and based on this the problems will be asked on this formula. Okay. So Arrhenius equation, rate constant K is equal to A into e raised to minus A by RT, where K is rate constant, A is energy factor, A is energy of activation, R is gas constant, and T is the temperature. Okay. Now directly we have third form of Arrhenius equation for two different temperature, that is log K2 by K1, that is equal to EA by 2.303 R T2 minus T1 T1 T2. So if the rate constant is given at particular temperature, at two different temperature, we can have this in order to calculate energy of activation. So this formula is very important. Based on this, problems may be asked. Okay. Last one is effect of catalyst on rate of a reaction. Okay. What is an catalyst? Catalyst is the substance which, when added in the reaction, it increases the rate or velocity of a chemical reaction. Okay. Now, as without adding catalyst and with adding catalyst, here graphical representation is given. There is effect of catalyst on rate of a reaction. So we can have potential energy on x-axis, reaction coordinate on y-axis. Reactant is taken. As rate or time passes, the energy activation increases. So here E is energy of activation, energy possessed by the reactant, and directly it will be converted into product. When catalyst is added, that catalyst provides the energy to the reactant and that much energy of activation is decreased. So this is EA dash is energy of activation with catalyst. Energy of activation without catalyst. So it is decreased. That means the rate of reaction increases. That much time is saved. That energy is provided to the reactant to convert into a product. Okay. So for 2 marks, they may be asked, represent graphically effect of catalyst on rate of a reaction. So this is what effect of temperature on rate of reaction and effect of catalyst on rate of the reaction. Here definition, energy of activation and temperature coefficient. This formula will be asked for 1 mark. This formula problems. Okay. So this is what today's lecture which we are going to have. Okay. So important part from the point of examination.